A particle moves such that at time t seconds, t being greater than or equal to 0, its position vector is r meters, where r is cos 2ti plus sine tj. So that is going to be, as a column vector, cos 2t and sine t. Find expressions for the velocity and acceleration at time t. So to get velocity, we need to differentiate. If we differentiate the cosine, we get negative sine. So it will be negative sine, the argument would be 2t because that doesn't change, but we have to use the differentiation chain rule, which means the inside function here, 2t, we need to differentiate that to get 2 and multiply by that. If we differentiate sine t, we get cos t. To get the acceleration, we need to differentiate again. Sine differentiates to cos, and we'd need to use the chain rule again for this one here. So we would get negative 4 cos 2t. And then for the cosine, we'd get negative sine t. Find the initial velocity and acceleration. Initial just means t equals 0. So v of 0 is going to be negative 2 sine 0 cos 0, and sine of 0 is 0, cos of 0 is 1, and that would be in meters per second. Acceleration of 0 is going to be negative 4 cos 0, negative sine 0, and again cos of 0 is 1, so that would be negative 4, and this one will be 0, and that will be meters per second squared. Find the Cartesian equation of the path of the particle. So, we have that x is equal to cos 2t. So that's just from there. And the y would be equal to sine t. So, using one of our trigonometric identities for cosine, that is going to be 1 minus 2 sine squared t, which means that x is equal to 1 minus 2y squared, or 2y squared is equal to 1 minus x. Sketch the path of the particle, taking care with the domain and indicate the direction of motion. Okay, so one of the things I might want to establish here is r of naught, which would be cos naught and sine naught, and that would give us 1, 0. Okay, so we have this equation. Now, normally that would be a parabola that is on its side, like this, or like this. Let's see which one works. So, if x is equal to 1, we would have that y is equal to 0. So let's just get ourselves some axes. Like so. So x is 1, y is 0, means we'd have vertex to the curve just there. What about x being 0? that would give us y squared equals a half, so y is going to be equal to 1 over root 2, plus or minus. So it's going to go here and here. And we can see, because this is a minus x, that the parabola must extend in this direction like this. But now we have to be careful with the domain and range. If we go back up here, we can see that both cos and sine, for example with sine is always between -1 and 1. Same is true for cosine. So in other words, this graph cannot go further than here, where x is -1. If x is -1, that gives me 2y squared is equal to 2. Y squared equals 1, y is equal to plus or minus 1. So this would be -1, 1, and this one down here would be -1, -1. Now, we've just established that we start at 1, 0. So this is the start point. So now let's think what happens. So we've got to look at this. We could try a few values, such as t is equal to pi by 4. If that was the case, we would have cos of pi by 2 and sine of pi by 4, which means that we would be at 0, 1 over root 2. So that's when it is at this point. And then if you try t is equal to pi by 2, we would have cos pi, which is -1, and sine of pi by 2, which is 1, 1 -1, and that means it would be here. So the initial direction of motion would be like so. But then it will come back along, and then it will come to this point, and so on. I'll probably just indicate the initial direction.